Good afternoon, everybody. Thank you for coming out to the lab today. Really happy to see you out. I'd also like to give a quick shout out to our vast audio radiance. So we'll have folks listening in now and forever. So that's awesome. Thank you for joining. Today I am here to talk about log analytics. Logs are perhaps the most dull subject on the entire planet until they're not. So logs are truly important. Logs are, I've been a developer, I've been a solutions architect. For my development days, if something was wrong, I learned the first place you go is the logs, right? So who's ever had sort of this challenge? The phone rings, it's 3 in the morning, and the servers are melting, right? Holy cow, the site's down, we're losing money, oh my gosh. So, and in this situation, if you have, say, 5 or 8 or 10,000 servers out there, you may be in a little bit of a pickle, because it's really not actually feasible to go log into every one of those 10,000 servers to find the one that's kind of broken, right? What you need is a central place where you're bringing your logging information so that you're able to figure out what's going wrong, right? And we'll get into it in a little bit, but some of the evolution of Elasticsearch, Elasticsearch started life as a search engine, right? Search engine is something like Amazon.com, where you go and type a product name and you search for a product and you get your product back, right? So why is Elasticsearch and logs even related to one another? Because people had exactly this problem. They had 10,000 servers, they had a bunch of logs, they needed to search for a problem, and light bulb goes off. Oh yeah, we'll put it in the search engine, then we can just type some queries and find out the broken server, the error, all of that stuff. So, and as Elasticsearch developed, it really developed capabilities around looking at the data that's in the logs and analyzing that data to allow you to build visualizations, graphs, dashboards, what have you, so that you could monitor everything that was going on. So that's kind of a quick evolution of Elasticsearch. This session is going to go perhaps slightly different than other sessions. We have a lab. We're going to kick off the lab first. We're going to do that for maybe 20 minutes. Then we'll come back and I'll start doing presentation. There'll be another break where we do a few more commands from the lab. I'll do some more presentation. And then at the end of it, you'll go ahead and finish the lab. So, to wit, the lab I have for you today is not actually DynamoDB, in spite of what it says in the schedule. I think we got ourselves confused a little bit. So who is familiar with CloudTrail? Barely anybody. So CloudTrail is an AWS service where other services send logging information about calls that are made against those services, right? Depending on the service, it's more or less granular. So some services you would get only information about things like creating resources or deleting resources. Some services like S3, you can get very detailed information about access to the objects in your S3 bucket. All of this is really useful information. It flows to CloudTrail. So CloudTrail has its own dashboard and its own way of letting you dig into that log information, but it's not actually Elasticsearch. It doesn't give you the kind of charts and graphs and really fine-grained ability to dig in. CloudTrail can send its data to CloudWatch logs, right? So CloudTrail sends it to S3, and it's in an S3 bucket, but you can enable it to send it to CloudWatch logs. CloudWatch logs, who's familiar with CloudWatch logs? Just about everybody. So CloudWatch logs is a log storage and alarming and metrics and dashboards, somewhat similar to Elasticsearch, but again, with a little bit less in terms of what you can do with that log data. So CloudTrail will send to CloudWatch. Then CloudWatch, through a subscription filter, can stream that data to Elasticsearch service. And so when it's in Elasticsearch service, then number one, it's searchable. It's a search engine. Number two, you can run Kibana, which is an open source thin web client that lets you do visualizations, dashboards, and all of that stuff. That's the setup of the lab. We have a CloudFormation template. And so let's go ahead and get started. The URL is there. That is the lab guide. So please go to that URL, and you can access the guide. You can download the guide however you like. There is a known problem with the guide which I can't figure out, and if anybody knows how to figure it out, please tell me. When you copy-paste the CloudFormation template name, it inserts random white space. So CloudFormation doesn't think it's an S3 URL. So after you copy-paste the URL, you'll have to delete the white space manually. Apologies for that. Stop at step 12. And I think we still have our same helpers. So if you have issues or problems, go ahead, raise your hand. We'll be here to help you out. Raise your hand if CloudFormation is already deploying for you. Okay, about half of everybody. We'll go a little bit longer. Owner of a white truck, work truck, parked in the alley, please come to the, no, I'm just kidding. I might have said this, but we'll start again at 1:45, so just 2 more minutes. Okay, so hopefully everybody has at least launched CloudFormation. and we will go ahead and move forward. I also realized I did not introduce myself. John Handler, hi, Solutions Architect with AWS. I specialize in Elasticsearch Service, and been with AWS for years, and so it's been a long time. I actually have about almost 9 years now been with AWS. So. That's me. Before that, I actually worked on an e-commerce website, designing a search engine, not Amazon.com, a different e-commerce company. So I have a lot of experience and history with search, and I love search. Search is cool. I did not hear that. I'm sorry. Right. So yes. So the question is, Elasticsearch is a good search and log analytics solution. How real time is it? And in all of the solutions that we offer for AWS, if you look at sort of the time scale, Elasticsearch sits pretty close to real time or at real time. Right. So Elasticsearch as a solution is really very focused on what's happening in the last 15 minutes or up to the present. Sometimes you go farther back, but in most log analytics use cases, it's really about what's right now. Right? Yeah, sure. Yeah, so like the question is around what about the other sort of real-timey analytics solutions like Dynamo Analytics, or not Dynamo, Kinesis Analytics, Dynamo Streams, what have you. If you look at the overall scope or scale of how long it takes to get data from the beginning to searchability, then you would see Elasticsearch is amongst the fastest. Like the amount of ETL that you do, the amount of work that you do to make that data go into Elasticsearch is kind of lower, and also there are tools that do it for you fairly automatically. Also, your scope with Elasticsearch is much expanded. So we're kind of starting at the end, but I'm happy to address the question. With Elasticsearch as a search engine, you get search for every field. And you get aggregatability and all of the analytics tools for everything, right? So it is, and you get natural language handling. So those are some of the differentiators for Elasticsearch versus, say, Yes, plenty of people use Elasticsearch for real-time. IoT is a use case that people do as well. Sure. Fraud detection, security information management, that kind of stuff. Yeah. Okay. So let me ask, who has significant or has any experience with Elasticsearch? Some folks, not everybody. Okay. Well, hang on to your hats. This deck goes pretty deep. But we'll start with some sort of more higher level stuff. What is Elasticsearch? Elasticsearch sits in the databases world. So from a million-mile perspective, you put entries or items into Elasticsearch, and then you run queries to retrieve subsets of those items, right? So it's a database in the sense that you're putting data into it, and you're storing that data. Elasticsearch does some kind of indexing in the back end, but then you can run queries against that data to pull data out. Now, it is not a relational database, so Elasticsearch not relational at all. It's not the ACID compliant, transactional, read after write. It is its own kind of database, and for that reason, it's specialized to do particular things. And I gave you a little bit of a description of that in the introduction, where I was talking about how people put log lines, they want to search, and they want to, et cetera, and do the analytics stuff. At a very high level, what you have is you have, on the one hand, you have information. So two main use cases for Elasticsearch. The first of those is log analytics, which we're addressing today. You have some server, you have some application, you have some network, AWS resources, what have you. They're generating log data. You flow that log data into Elasticsearch. Elasticsearch does some magic behind the scenes, and then you access it to either search it or visualize it. The other significant use case we see is the search use case. So Elasticsearch is a search engine. Generally, for an application, you'll have a database of some kind that has the information for that application. For e-commerce, you'd have like a product catalog in a database somewhere. You would push that into Elasticsearch. Elasticsearch then, via API, provides your front end the ability to query against your catalog of products or what have you, and bring that information back to your customer, hopefully for a purchase, right? So those are the two main use cases. And the access pattern is pretty simple. Push a bunch of data in, and then query it, right? So we have Amazon Elasticsearch Service launched in 2015, mostly in response to customers having trouble and frustration deploying and maintaining Elasticsearch clusters. Elasticsearch, tremendously easy to get started. Really cool piece of software, fast time to value, like proves itself very quickly. And then as you start to scale and push more and more information in, you start having to deal with multiple nodes in a cluster. You start having to deal with doing replacements and software upgrades and all of that stuff. So the service really is designed to take that undifferentiated stuff and do it for you and allow you to run Elasticsearch simply in the AWS cloud with our normal sort of backend, and we'll get into it. And specifically in the log analytics space, and I encourage you, this was a reInvent session from this year. Autodesk presented about how they use Elasticsearch to centralize their logs. They have a lot of different groups across the company who are application developers or what have you. They're all generating these log files, and we see this a lot where individual developers are doing cool stuff with Elasticsearch, and then the company sort of sits up and notices and says, hey, we're spending kind of a lot of money on this stuff. Maybe we should try and manage it a little bit more closely. So Autodesk is a good example of that, and one where they took a number of different applications, flowed all that data to Elasticsearch via Kinesis Data Firehose, and then provide search across that data. So it's a really nice session from reInvent, and if you're interested in log analytics, they have some really good best practices. But coming back to the service a little bit, so with Elasticsearch Service, we see some primary benefits. Again, number one, we wanted to bring out a product where you could use the regular open source tools that you're used to in using Elasticsearch. So if you're already using Elasticsearch and you're used to Kibana, you can use Kibana. We expose the Elasticsearch APIs directly through an endpoint that you can use Elasticsearch APIs directly. If you've written code against Elasticsearch, if you have Kibana dashboards, all of those things will work in the service as well as with self-managed. So we wanted to make it easy to use. We make it so that in the console, you do a few clicks. You say, hey, I want an Elasticsearch cluster. It should have this many instances. It should have this security. It should have this kind of encryption. All of that, we go off, deploy all of the hardware for you, build it into a cluster, and give you an endpoint. So you can just use it. We make it easy to scale your cluster. If you have a certain number of instances in your cluster and you want to have more, you just click, 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 and we go off and do that for you. We make it more secure. So we have a number of different security features, and we'll get into those in depth. We make it more highly available. With a click of a button, you can deploy it across multiple availability zones, gives you resiliency in the face of zone or even instance failure. We do have 24/7 operations and monitoring. When clusters get in trouble, we can frequently step in and fix those clusters and bring them back up for you without your intervention. And we have a number of integrations with other AWS services. So if you're using CloudWatch Logs, as we saw in this one, you can flow it in there. Database migration service also can deliver to Elasticsearch. So if you have a database of products and you want to migrate it over to Elasticsearch, you can do that pretty easily. Kinesis Data Firehose, direct to Elasticsearch. We also have Lambda as a sort of Swiss Army knife where a lot of customers use that to deliver their their data to Elastic. Well, it is, right? OK, so in terms of what you get, we have several methods for deploying Elasticsearch Service domains, is what we call the collective. And you can use the console, command line tools, CloudFormation. What else did I put up there? Oh, other AWS tools and SDKs, sure. You can use all of that stuff. You say go, and we deploy for you in AWS a cluster of instances. So there's a couple of things here. First of all, Elasticsearch is a clustered solution, right? So you have a number of instances that are running Elasticsearch software. They're all communicating with one another behind a load balancer where you're sending your requests. So you send your requests, they're sent off to the data nodes. The data nodes process those, send back the responses, right? In addition, in Elasticsearch, we have a concept of a master node. A master node is, if anybody's familiar with Zookeeper, master nodes are kind of like Zookeeper, but they're not Zookeeper. They're their own software. They're responsible for holding the cluster state, keeping track of all of the schema that you have, keeping track of the location of where the shards, and we'll get into that, where the shards are, where all of that stuff is. Again, all behind load balancing. We publish an endpoint in Route 53. You refer to that endpoint, and you use a REST API to send your calls to Elasticsearch. Right? On the back end, we send audit calls to CloudTrail, and we send a bunch of different information to CloudWatch logs about how your cluster is performing so that you can alarm on that and adjust. So how does Elasticsearch work? We'll get into this a little bit. This is an example of an Apache weblog line, or a set of them, that is it's an open data set. This is NASA, July of 1995. All of my colleagues kid me that I should really get into the 2000s already. But it's kind of cool. It's the NASA website, and covers July of 1995, and there's like a rocket launch, and so it's a neat data set. 2 shuttle launches, actually. So the main idea here is each of the log lines in that big weblog constitutes an entity. That's something that you're going to potentially search against or aggregate, right? So each log line is an entity. Now, those entities that you send to Elasticsearch are called documents. In Elasticsearch, a document is just a collection of fields and values. And so you're going to cut up the source data, format it into JSON, and send it to Elasticsearch as a document. And that looks like that. It's really pretty straightforward, right? I mean, you have the fields in your log lines. You're just assigning field names to them in the JSON and then sending that document to Elasticsearch. Elasticsearch does handle nesting, right? So for more complex, either logging solutions or data solutions, you natively can nest JSON inside of itself, and you get .path access to the underlying values that are there. So I keep saying you send it to Elasticsearch. Actually use the indexing APIs to send data to Elasticsearch. Again, it's a REST interface, right? So pretty easy. You call the index API, and you say, here's my document. That's the simplest way to do it. But actually, most of the tools that are out there will automate calling this API for you, and they'll do that with the bulk API. The bulk API lets you send a batch of documents, interleaved commands and documents, off to Elasticsearch. It's just a post. When you send that post to Elasticsearch, so Elasticsearch then is going to take all of the fields that you have, and it will analyze the values in those fields according to a schema that you set, and create indexes on that. So how does that look? So let's say, for instance, I have a host name field, and I'm going to analyze that as a string. Actually, there's an IP address as well, but a lot of times in weblogs, you have host names as strings, right? So I tell it it's a string. Elasticsearch looks at that and decomposes it according to the string rules, right? There's 2 kinds, but we won't go into that detail. But there's 2 kinds. Elasticsearch analyzes, it comes out with a set of terms. These are the targets for matching, right? If it's a name like John Handler, then it would come out with 2 terms, John and handler. If it's an IP address like this, we're probably not going to decompose that. It's probably going to be just the, host name. It's just going to be the host name. I'm going to take that and I'm going to put that into an index, right? So index is just all of the terms that I've seen. My host name will be an entry in the index. If it were names, John would be an entry and handler would be an entry, right? It points off to what's called a posting list. This is the ID for every document that contained that. Right, so if you think about like what is an index, right? So encyclopedia, anybody ever seen a physical encyclopedia? Wow, vanishingly few. Encyclopedias were these really big sets of books that had articles about anything you could want. Wikipedia, right? Only on paper. And of course, paper has the normal problem with paper, which is that if you want to find something, well, you can start at page 1 and go through really quickly. Or you need some kind of index, right? Index, what does it do? It points to all the pages that contain the articles that you're looking for. I search for Barack Obama, I see 1, 12, 47, 83, whatever. Same thing with Elasticsearch. I've got a set of log lines. They all have hosts. The host field has each entry pointing to all the log lines where that host appeared. This is the central data structure of a search engine. It's how we do fast search. When I'm searching this thing, I'm going to go to the index and I'm going to look it up very quickly because it's binary search, and I'll find all of the documents fast. Before I describe that, I'm just going to quick say, again, I mentioned you set a mapping to control the decomposition of the text values. So Elasticsearch supports a number of different types, native types, things like floats, doubles, longs, integers, geopoints, dates, as well as text. And I create my mapping by posting to my endpoint, and I say, okay, properties, the verb field is a type keyword. And the, size field is type int. And the verb here, I mean HTTP verb, right? Because this is Apache Weblogs. This makes sense? Everybody's kind of going blank. So I'm going to tell Elasticsearch how I want that thing decomposed, and that's what Elasticsearch is going to put in the index. So when I, yes? So it makes an index unless you tell it not to. So the question is this indexing at the object level, at the field level, what? Elasticsearch creates an index at the field level for every field unless you tell it not to. I see. So question is, is there query optimization in there? And yes, there is, but it's a distributed system, so it's hard to do much in the way of query optimization. That is sort of an ongoing project that the Elasticsearch team is working on. So yes, there's some optimization in there, but you generally try to write a good query rather than rely on an optimizer. Yeah. So when we get to querying, right, and let's say I'm querying for host X and response size greater than 10 million bytes and status code 404, whatever, right? So I'm going to search the host field. I'm going to search the response code field. I'm going to search the size field. Elasticsearch goes to the field indexes, right, and pulls out of the index the values that I'm searching for, right? This is really quick. This is like binary search. To find the host name, it just bing, 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 and it finds that's the host name, right? For the size range, it's more complicated. We don't have to talk about that. So once it's got the posting lists, so let's say this is an AND query between 3 different terms, right? This and that. It pulls the posting lists. That tells me all the documents that have term 1, all the documents that have term 2, and all the documents that have term 3. So then what I do is a set intersection for AND, between those sets of posting lists, right? If I want to see term 1 and term 2 and term 3, it's the intersection of all the documents that contain term 1, 2, and term 3, right? That's also a fairly fast operation. The first one is binary. This one is like linear, but it's kind of linear in the shortest one, and there's all kinds of optimizations built in. This is fast. I emerge with a set of matches. These are all of the documents that have the correct criteria to be in the result set. I then walk that list, score all of those documents, and sort everything in relevance order, in score order. Okay? That one's the slow one. It is the differentiator between Elasticsearch and other database solutions in some ways. Elasticsearch has a built-in notion of scoring where you want to retrieve the best stuff, not all the stuff. Right? Most databases, you issue a query, there's 100 million matches, you want to get 100 million matches. With a search engine, if there's 100 million matches, you only want to get the best 10, right, usually. I don't know if you've ever tried this. You can hack the Google URL. It gives you a page number, right? If you try to go past result 1,000, you can't. It won't serve it back to you, right? Because, again, search engines optimized to do fast, relevant search. Yes?
So relevance is frequency of occurrence?
So I'll give you a quick answer. So relevance is the default relevance that comes out of the box is a statistical measure of how frequently the terms you're searching for occur across all of the documents, right? So if I'm searching for John, it's probably a pretty common term. It probably has 87 million instances. If I'm searching for handler, okay, well that one's probably pretty common too. But imagine it was a really rare name, that would have a few. So if a term is very frequent, it's not very valuable in terms of relevance for discriminating between documents. If it's rare, it is very valuable. So I take the score for each of the terms in the query, and I multiply by how many times it occurs in that particular document, and I add it up. That's a default relevance. Relevance is its own long topic. There's many, many, many other things you have to do. Because it's statistical, like if all my documents kind of look the same, then I'm not going to have a lot of discrimination from just doing the statistics of how often the terms occur. And at that point, I want to bring in stuff like maybe a ranking, like if it's an IMDb, maybe I know that this is a really popular movie, right? So popularity. Maybe it's user-generated content. Maybe I know this is an important user. Maybe I can look at the link structure and decide that, hey, lots of people point at this thing. Maybe this is authoritative, right? So there's all kinds of ways that you augment that base score. So some of the things we can do, we can query our logs directly. And I just wanted to give you an example just to look at sort of what does the round-trip query look like. Elasticsearch has a URL-based query language and a JSON-based query language. The JSON-based language is kind of more common. And unless you're writing an application, you don't frequently write these JSON queries. But it's just query. I'm looking for a term in the verb field, and the term should be get. When I look, I have even some cool graphics. So I have a metadata section in there that shows me how long it took, how many shards it hit, how many were successful. And then I have this section of hits. These are the original documents that I sent in as JSON, right? So I pull all this information back out along with my query result, right? Oh, it tells me how many hits too. 499,000 GET requests to NASA in July of 1995. Important historical information. Okay. The other thing you can do is you can create visualizations. So I might want to also look at a particular time frame, and I might want to say, okay, well, let's graph out how many gets, how many puts, how many posts, how many hits, right? This is the kind of thing I would use to monitor to make sure that my website was receiving traffic and people weren't trying to go through the back end and post stuff to my website. So how do we support this? Well, if you think about it, I have some result, right? So I've sent a query that says verb is get, okay? I have some result that looks like a gajillion documents, 499,000, where the verb is get. I go back to the original source data. So I now have 499,000 log lines, all of which are get log lines. I go back to the source data, and actually in this case, maybe I want just whatever the verb is. So I pick a host, something, to query. I create buckets for each of the values, get, put, post in this case, right? And then I just count how many times each of those occurs. And that is a histogram, right? And I can graph that visually like that. Well, okay, not that histogram, but that's how I do that. As you go through and play with Elasticsearch and Kibana, keep in mind what you're really doing is narrowing to a specific set of documents and then doing aggregations on the field values for particular fields that you're specifying, right? That is what Elasticsearch does. That's how Elasticsearch does analytics. Okay, so that is the fundamental underlying kind of what is Elasticsearch. So let's pause there. Like, any questions or thoughts?
Based on what you said, it's more immutable data that extract or transactional field. So sometimes people get confused with the transactional. That's why I was asking that in the context of transactional field analytics, it may not be very optimal to use Elasticsearch. But then the update occurs because it's not immutable. You want to relate the updates and you want to know what has changed and then metrics are more trustable financially. That's not the right real use case.
So, okay, so the question is around mutability of the underlying data and sort of how that ties in with analytics in real time, right? And Elasticsearch, first of all, data is mutable. You have to know which log line you want to change, but you can change it. And in terms of what you usually do with Elasticsearch is you're looking across a time frame as a primary filter, right? You're building some kind of bucketed time scale x-axis that lets you build graphs, right? That's one way of looking at sort of real time, right? As opposed to what is changing. So you can still do what is changing, right? You can graph, right?
Example, how we would time series is pretty good for transactional change history, kind of like a sales transaction, those kind of things. And then we want to do sales transactions. What is the current state?
Yeah.
And those are all may not be very good use case or optimal way, but that's what I want to get. If you want to get
Right.
real time.
So I'm going to disagree and say, so the question is like, well, if I'm going to graph something, if I want to know sort of what are my sales right now, Elasticsearch is actually really good at that. Because we'll see, but Elasticsearch dashboards allow you to continuously update the view of what you're seeing, and so as you're looking at a chart, you see it change in real time. So Elasticsearch really is a real-time solution, I promise.
Yeah, I've seen mostly on the log analytics that it's immutable, it's just history is appended, you relate them.
Right. So yes.
What penalty you pay and
Yeah, so a lot of times, yes. So what a lot of customers, you have real-time focused customers and you actually have longer scale focused customers. Elasticsearch can do both. Most people are more focused on the real-time component, not the longer-term analytics. For that, we usually, well, we'll get into it. Why don't we go look at this? Maybe this will be helpful. Let's talk about data lifecycle, right? Especially, and when we're talking about log analytics domain, we have a number of data producers which might look like my front-end web servers, they might look like my AWS resources, they might look like my application where I'm doing application performance monitoring, they might look like distributed tracing. All of this data is generating logs, right? And so what I need to do is collect all of that data somewhere so that I can transform it, because remember, it starts out as strings and it needs to be JSON. So I have to do a transform. And then I'm going to push that into Elasticsearch. Now, the other path that we generally see here is that when you're collecting it, you frequently want to push it off to a cold store where you're going to do longer-term analysis with something like Athena or Redshift Spectrum or what have you, right? So S3 is a very common destination for all of this log data as well, right? And ultimately, you're going to do analysis and reporting out of Elasticsearch and also out of that longer term store, right? At the end of the whole cycle, usually because Elasticsearch is a hot store, it can be costly to hold a lot of data in it. So generally, you're going to age data out of Elasticsearch. That's why you've got S3 to hold that data for longer term. Right? Was there a question?
I just wanted to ask, you never mentioned Logstash.
Oh, wrong slide. Wait, oh, there it is. So we have good questions and great questions. This is an example. Great question is when it's the next slide. Great question. I stole that from a friend of mine who's probably going to see this, and then he'll make fun of me. OK, so if we actualize this in terms of some particular architecture, this is a pretty common architecture that people use. I have a bunch of servers. There's an open source technology called Beats. And Beats are lightweight log shippers. They sit on the data producer. There are a number of different flavors that ship different kinds of logs. They do all kinds of annotation and extra stuff to make your logs more searchable, more visualizable. Basically, they just ship. Their target here in this case, we would use a load balancer. This is going to kind of depend on volume, whether you need a load balancer or whether just one Logstash is enough. But you either load balance across an auto-scaled set of Logstash hosts, or you just send it to one. So what is Logstash? Logstash is an open source ETL over streaming data. Okay? Fundamentally, with Logstash, you set up an input stage that reads data from somewhere. And there are inputs that read from Redis and from, oh gosh, from Beats and from all sorts of places, relational databases, et cetera, et cetera, et cetera. There's like 60 of them. You then have a transform phase where Logstash is going to take the strings, it's going to parse them up. There's a regex matcher that can do, say, Apache weblog lines. So it's like a simple configuration to send your weblogs through. Can take weblog lines, can do other random stuff with your data. It emits JSON. And there's an output phase that can send to, again, a long list of destinations, most relevant Elasticsearch, right? When you have that, then Elasticsearch, you're going to use Kibana to view. And as we said, Kibana is a thin web client. We're all going to be Kibana experts by the end of the day. So you'll know lots about Kibana. One other thing to point out, this particular slide is depicting Elasticsearch service launched into your VPC. We support that through Elastic Network interfaces. In order to visualize anything, you have to be able to get your traffic to Elasticsearch from Kibana. That's the purpose of the bastion up in the top left. So that's a very common pattern. Use some kind of bastion or proxy that passes traffic securely into your VPC into Elasticsearch service. This one here? Can you use Logstash on Lambda? No. Oh, when is it appropriate Logstash? When is appropriate Lambda? Well, in some senses, it's a flavor, right? I mean, Logstash has certain capabilities that make it's designed exactly for this. So using Logstash is very easy to do. Logstash has its own, you're running it on your own servers. You're responsible for managing it. You're responsible for keeping it up and running. Logstash scaling is also not very straightforward. Lambda has the minus of not having built-in regex matching and all that other stuff that Logstash does for you really nicely, including persisting a translog and in case something goes down, and retrying and adaptively adjusting to Elasticsearch's back pressure signals. So it's kind of a flavor of the month, whatever you want to take on. Another very common pattern then is this one where your producers are using either, say, the Kinesis agent, which is also a lightweight log shipper, which also sits on your host. So I've been given the hook almost, but thank you. But we're doing this whole thing interactively. This is gonna be great. What happened? Yes, Kinesis. Kinesis agent ships to Kinesis data streams. Kinesis Kinesis data streams, and then Lambda transforms and ships. I can go quicker. I probably should. I have only 120 more slides. That was a joke. We don't really have 120. OK, so special case Firehose. Kinesis Data Firehose is a really, really nice solution for shipping data to Elasticsearch. Really love it. It does not deliver to the VPC. That makes it kind of a second runner at the moment, but hopefully someday it will be able to deliver into VPC. So what we have here is data comes into Kinesis Data Firehose. The Firehose automatically triggers a Lambda for every log line in there, and you can write your transform in Lambda. You deliver it back to the Firehose. Firehose then delivers to Elasticsearch Service the transformed records. The nice thing about Firehose also delivers to S3. So you can archive everything off while you're sending it off to Elasticsearch. It also handles buffering, so you can set buffer sizes, and it also handles retry and error failures. So Firehose is really nice. If you don't need your Elasticsearch Service domain in a VPC, I recommend Firehose. When you use Elasticsearch, and again, we're sort of talking about data lifecycle in general, you create indexes in Elasticsearch. For log analytics, you create an index every time period, usually every day. So what you have is a rolling set of indexes for today, yesterday, the day before, day before, day before, day before. To do the lifecycle management, then, you just delete off the oldest index at the end of the cycle. It's like dropping a table, which that's the right way to do it. It's not right to put it all in one index and try to delete the documents one at a time. That's bad. Dropping a table or dropping an index, much more performant than trying to delete a million bajillion documents, right? In the indexes themselves, then I'm sending data into the index, and I specify a shard count. So what is a shard? A shard is a subset of all of the data that I'm sending to Elasticsearch. If I have 100,000 log lines and I have 5 shards, each shard has 20,000 log lines, right? You just split the data across those shards. Then Elasticsearch is going to deploy shards to instances. So index is a high-level concept. It's comprised of shards, and then Elasticsearch puts those shards onto instances elastically. That's why it's Elasticsearch. If I add more instances here, it'll shuffle around the shards so they're distributed evenly. We also have a notion of a replica shard. So the first shard is called the primary. I set my primary shard count. That controls how many shards I have. I can have dynamically n replicas. The first replica provides me redundancy. Elasticsearch deploys the first replica to a different node than the primary. If I lose a node, I retain the data in that second one. You should always have one replica at least. Additional replicas allow you to scale for query traffic. So if I have a lot of queries, then I can replicate my shards and I can add instances, and that's how I scale horizontally. When you create indexes, as you saw, you set a mapping. Now, it might occur to you that, well, OK, so I'm going to create an index every day, and what am I going to do? Like, go make at midnight, I'm going to sit at the keyboard and really send off my, create the index. So no, you don't have to do that. Elasticsearch will automatically create indexes, and then you can set what's called a template to apply the settings that you want for every index that gets created that matches a wildcard, OK? So in this case, we have a template. We're setting number of shards to 2. We're setting the number of replicas to 1. And I have one mapping in there. The verb is a keyword, right? Anytime I create an index that matches log source 1 --, these settings are applied to that index. That means my automatic tool, which is flowing data like logstash is flowing data, it will start flowing into tomorrow's index at midnight, 0.1. And it will then, Elasticsearch will create the new index with these settings. As I mentioned, at the end of the data's life in Elasticsearch, one thing you might want to do is to archive off the index to S3. You can do that with Elasticsearch's snapshot API to send that single index to S3. Then you're going to delete that index. That's an optional step. If you already have all your source data in S3, obviously you don't have to do that. Yeah. Correct. Yeah, so if you have your source data, you don't need to archive off your index. I don't have a solid answer about whether it's faster to restore a snapshot or faster to reindex all your data. It's not clear. I mean, you have to flow all the data in either case, right? So anyway, you're going to run a cron or scheduled Lambda or what have you that every day will delete the oldest index. And this is bounded by a retention period that you decide. I want to keep 7 days worth of indexes. At the end of day 8, I go delete day 8's index, and I keep going. There is an open source tool called Curator that does some of this management for you. You can run it against the service. OK. Well, I didn't talk for that long. We have now a little interlude here. Everybody's going to return to our lab, and we're going to type 10 more commands. So please return to your lab and go until step 20. Sorry?